Okay, problem 8.28, discuss the convexity of the following functions. Okay, so again, the convexity has to deal with the sign of the first derivative that's non-zero after the first one. Okay, typically it will be the second derivative. So we want to compute the second derivative of these functions and see when they change sign, right? So this is f is x minus 2 times x to the 2/3. The first derivative of this is going to be x to the 2/3 plus 2/3 of x minus 2 times x to the minus 1/3. And the second derivative is going to be 2/3 times x to the minus 1/3 plus 2/3 of x to the minus 1/3, or in other words 4/3 of this. Let me rewrite it already. 4/3, and then we have the derivative of this is minus, let's see, this is minus 2 over 9 times x minus 2 times x to the minus 4/3, right? Now, when is this going to be greater than 0 or not? Let me see if I can, we can get a common factor, let's say, first 2/3, right? We have 2/3 that multiply, and then x to the minus 4/3, right? So this multiplies, this is 2 times x, right? If I'm correct. And then we have minus 2x, yes, sorry, minus 2x, no, minus x divided by 3, sorry, minus x divided by 3, minus x divided by 3 plus 4/9 or 2/3, right? Yes, so then we have this is 6 minus this is 5x over 3. So what we can get here, this is 9x to the 4/3, right? And then we have 2 times this is 10x plus 4, if I'm correct, right? Now, when is this positive, when is this negative? Obviously, if 10x plus 4 is greater than 0, then the second derivative is going to be positive, right? So when x is greater than minus 2 over 5, then the function is going to be, wait a minute, because it depends also on the sign of this, right? So let's see, we have three different regimes, right? So either x is smaller than minus 2 over 5, then x is between 0 and minus 2 over 5, and then x is greater than 0, right? So if x is smaller than this, then this is negative, but this is also negative. Wait, so no, sorry, this is always positive. So minus 2 over 5, right? So this is always yeah, so I don't know why I said this, because this doesn't change anything. So if x is smaller than this, then the second derivative is negative. So the function is concave there. And if x is between these two, this is the second derivative is going to be greater than 0. So the function is convex, right? I mean, yeah, so I wanted to separate at 0 because at 0 this is not defined, right? So it could be the case that at one part and the other of the on the asymptote it would have a different sign, but in this case it's not the case, right? So the function is concave if x is smaller than minus 2/5, and convex if x is greater than 2/5. Okay. Okay, let's do second. Let's write it in parts, right? So this is x times e to the x when x is greater than 0 or greater or equal than 0, and then minus x times e to the minus x when x is smaller than 0, right? Now let's compute the derivative, and sorry, the derivative of this is x e to the x plus e to the x, or in other words, when x is greater than 0. Sorry, let's see, it's when x is greater than 0. We don't care if it's differentiable at 0 or not. Okay, and then we have this is minus x e to the minus x. No, sorry, plus x e to the minus x minus e to the minus x when x is smaller than 0. Or in other words, this is x plus 1 e to the x, and this is x minus 1 x minus 1 e to the minus x. Now we compute the second derivative, and using the same argument, we just see this is x plus 1 plus 1, so it's x plus 2 e to the x when x is greater than 0, and x minus 1 minus 1. So you can see this is minus x plus 1 plus 1, so this is minus x plus 2, 2x minus 2 minus x e to the minus x, yes, when x is smaller than 0. Okay, now what happens here, this is always going to be positive, right? Here, if x is positive, then the second derivative is positive, and then here if x is negative, this could be negative if x was greater than 2, but x is negative, so this is also going to be positive always. So the second derivative is going to be positive, so this function is convex everywhere. Okay, and now let's do the third part. The third part is f is the logarithm of x squared minus 6x plus 8. And you can actually factor this polynomial. You can see that this is actually x minus 4 times x minus 2 if you get the roots, or in other words, that this is the logarithm of x minus 4 plus the logarithm of x minus 2. So the first derivative is just 1 over x minus 4 plus 1 over x minus 2, and the second derivative is minus 1 over x minus 4 squared minus 1 over x minus 2 squared. So this is always going to be negative, right? In the domain, right? So this function is always going to be concave. Okay?